Welcome back. Today we are going to be learning how to solve one-step equations. And if you've been following along in your workbook with us, we have been learning how to evaluate algebraic expressions. And really, equations is just a continuation of that learning and understanding. So if you haven't watched those videos already, be sure to check out the links in the description. That will really help you moving forward with our learning for today. So we'll be looking at the four operations and how we can take the inverse operation to solve for unknown amounts. So we'll go over some practice problems and look at some word problems and cover a few quick vocabulary terms. So let's go ahead and start with that. Welcome. Real quick, before we look at those vocabulary words, I forgot to mention, if you're following along in your workbook, the workbook actually, this chapter outlines solving one-step equations and inequalities, and it's really a lot of information to go over in one lesson. So I'm going to break it up into two separate videos. So the video following upcoming the next lesson will be on solving one-step inequalities. So be sure to be on the lookout for that and subscribe. That way you can get notified for every weekly lesson that comes up. So let's get into our vocabulary words. First, we have an equation, and an equation is a mathematical sentence showing two expressions that are equal. So like I said before, equations are really an extension of an expression. An expression has numbers and operations and a variable. An equation is just adding the second half to that. It's putting in the equal sign and saying what the value equals from each side. So what differentiates an expression from an equation is that equal sign. And so we're going to look at this example here, x plus 7 equals 12, and we're going to look at how we would solve this. So our next vocabulary term is inverse operation, which you'll hear directions like use the inverse operation to solve the equation. So inverse operation means to take the opposite operation of whatever's in the problem in order to isolate the variable or solve for your unknown amount. So for example, if we had x plus 7 equals 12, the operation that we see is addition. The inverse operation of addition would be subtraction. So subtraction would undo addition. And so in this example, we would subtract 7 from both sides to solve for x. Now, again, this is very much the procedural way that we will go about solving a one-step equation, but it's very important to remember in mathematics, part of my goal for teaching you is not just how to do it, but why we do it. So we want to think about what we're doing and what we're asking. So when I say x, a number plus 7 equals 12, you're thinking to yourself, what number plus 7 equals 12? And a lot of you don't, you kind of intrinsically will already subtract and say, oh, well, 12 minus 7 is 5. So it has to be 5 plus 7. And that's kind of, you think of that without having to say, okay, I need to subtract and then I need to follow this step. And so again, as we go through this, we want to be thinking about, okay, what is the problem asking? A lot of the times with one-step equations, you can really solve them in your head if you just think about what the problem's asking. But we are going to go over those procedures of what it looks like mathematically, step by step for using the inverse operation. So let's get into it. All right, we are going to do an example of each operation, adding, subtracting, multiplying, and dividing, and we're going to start here with number 1, solve each equation for the unknown variable. And so we have x plus 7 equals 15. So we're going to start right here with number 1. And first we just want to think about this logically. What number plus 7 equals 15? Do you know? If not, now we are going to use the procedural way, which is to use the inverse operation. So the opposite operation of adding is subtracting, which means we would subtract 7 from both sides of the equal sign. And sometimes people like to write a line right here to keep their work organized. And so then we would have x plus 0 gives us x, and 15 minus 7 gives us 8. And if that was what you were thinking the first time, yeah, 8 plus 7 is what equals 15, right? If we think about it logically, that's just what the question is asking us. What number plus 7 equals 15? 8 plus 7 equals 15. And we know that because 15 minus 7 gives us 8. So that's our answer for number 1. Number 2, we want to think of the same way. What number minus 9 would give us 11? What number minus 9 equals 11? So procedurally, we see subtraction here. We're subtracting, and so the inverse operation of subtracting, the inverse is the opposite, is adding. And so if I add 9 to both sides of the equation, this would give me 0, and x plus 0 is x, and then 11 plus 9 is 20. So if you thought, yeah, 20 minus 9 is 11, okay, that's what we're just asking. What number minus 9 is 11? It's 20. If we add 9 to both sides, we get our answer, x equals 20. All right, let's look at number 3. So for number 3, we have 3x equals 18. Remember, this means 3 times x, so we're going to identify the operation that we see first, which is multiplication. So the inverse operation of multiplication is addition, or not addition, division. So we are going to divide both sides by 3. And 3 divided by 3 is 1, and 1 times x, any number times 1 equals itself. That's how we get x. And then 18 divided by 3 equals 6. So x equals 6. Same thing, if you think about it, what number times 3 gives us 18? Yeah, 6. If I have my multiplication times tables memorized, I know it's 6. 3 times 6 is 18. So x equals 6 is my answer for number 3. So for number 4, we have x divided by 5. Remember that all fractions are division problems. And so this line right here, x over 5 means division. X divided by 5 equals 4. So to undo division, the inverse operation of division is multiplication. So we are going to multiply both sides by 5. And the reason why is this would give us 5x divided by 5, and 5 divided by 5 equals 1. And then 1 times x equals x. Okay, so a lot of the times people like to say it cancels out, and I don't like to say that. I like to explain what happens so that you know mathematically what we're doing the operations. We're doing 5 divided by 5, which gives us 1. We're doing 1 times x, which gives us x. Numbers don't just disappear. Okay, so we got to think about what's happening and understand why it's happening. And then we're going to multiply both sides by 5. So we already did it on this side of the equation. Now we do 4 times 5, which gives us 20. Same thing if you go back and think, what number divided by 5 equals 4? I know that 4 times 5 is 20, so 20 divided by 5 is 4. Okay, so our answer is x equals 20. So we just did an example for each operation. Here we did addition. The problem had addition to start, so the inverse operation of addition means that we subtracted. So we subtracted on number 1. For number 2, we had x minus 9. So for subtraction, our inverse operation is addition. We said it was subtraction here. Okay, and then we solve for x. On number 3, we have a multiplication, and the inverse operation of multiplication, if we multiply, we're going to divide. Okay, and then lastly, we did division. All fractions are division problems, so the inverse operation of division means that we multiply both sides. Okay, and remember, we always want to think about what we're doing and make sense of it, not just follow steps and memorize steps. So you can always go through, remember that x just represents an unknown amount. So you could think in your head, what number minus 9 equals 11? Oh, I know that. That's 20. Okay, so you can think through these problems logically as well. And if you want access to the rest of these practice problems, check out the link in the description to get your own copy of the complete 6th grade workbook. So we just did some practice problems solving one-step equations. We even did a few word problems, and hopefully you're walking away having a better understanding of what inverse operations are. If we're adding, we know that we can undo the operation by subtracting. If we're multiplying, we know we can undo the operation by division. But really what I want you to walk away with this lesson is that think about what you're doing. A lot of these problems you can kind of solve in your head as you work through them. We don't merely want to just memorize steps in mathematics. We want to make sense of what we're doing and why we're doing it. So our next lesson is going to be on solving inequalities. So make sure that you've subscribed so you can get that notification when it comes up. And if you are interested in having your own copy of the workbook that we're working through, go ahead and visit theblazehaven.com. Those links are in the description. Thank you for watching, and we'll see you next time.